Hello guys, my name is Shreyas. I'm a BTech second year triple E student studying at NITK Sulatkar. Today I'm going to talk about how to implement Watchdog timers in Arduino. I like watching anime like One Piece, Attack on Titan. I've once finished 900 episodes of One Piece in 1.5 months. Just to give a brief intro, Watchdog timers are used to prevent system failures due to a software or hardware hang. While doing my internship at FluxGen, my final task was to implement Watchdog timers on Arduino. This is how I got introduced to Watchdog timers. As I read about Watchdog timers, I understood how important Watchdog timers are. As you might have guessed, in today's influx talks, I'm going to talk about Watchdog timer. A Watchdog timer is an electronic timer that is used to detect and recover from computer malfunctions. During normal operations, the computer regularly resets the Watchdog timer to prevent it from elapsing or timing out. If due to a hardware fault or program error, the computer fails to reset the watchdog, the timer will elapse and generate a timeout signal. The timeout signal is used to initiate corrective action or actions. The corrective actions typically include placing the computer system in a safe state and restoring normal system operation. As you guys can see here, this is the block diagram of the watchdog timer. So here the computer keeps resetting the watchdog timer so that the watchdog timer doesn't time out. And in a case where the watchdog timer times out, then the watchdog timer will initiate a computer reset. For example, let's assume that the watchdog timer is set to a timeout window of 2 seconds. So if the computer doesn't reset the watchdog timer within 2 seconds, that means the computer has hanged. In that case, the watchdog timer times out and it initiates a computer's reset. Watchdog timers are commonly found in embedded systems and other computer controlled equipment, where humans cannot easily access the equipment or would be unable to react to faults in a timely manner. In such systems, the computer cannot depend on a human to invoke a reboot if it hangs. It must be self-reliant. In one famous case, a NASA Deep Space Probe's computer locked up with the thruster rockets firing. By the time the ground controllers realized the problem and sent a radio signal back to force a hardware reset, the probe had already used all of the fuel. The processor had a watchdog timer, but it was not used. A watchdog timer would have likely detected the fault and shut down the rocket motors in time to save the mission. The process of restarting the watchdog timer's counter is sometimes called kicking the dog. The appropriate visual metaphor is that of a man being attacked by a vicious dog. If he keeps kicking the dog, it can't ever bite him, but he must keep kicking the dog at regular intervals to avoid a bite. For example, the kicking of the dog can be referred to as resetting the watchdog timer, and the bite can be referred to as a system reset. So if you do not keep resetting the watchdog timer at regular intervals, then the watchdog timer will time out and it will initiate a system reset, which is referred to as bite. I will now show you how to implement watchdog timers in Arduino. So this is the Arduino code. I've included the AVR WDT function. This function is used to call these three functions: WDT disable, WDT enable, and WDT reset. So WDT disable is used to disable the watchdog timer. Now I'm going to talk a few things about the watchdog timer used in the Arduino. The watchdog timer uses an internal 128 kilohertz clock source. When enabled, it starts counting from 0 to a value selected by the user. If the watchdog timer is not reset by the time it reaches the user selected value, the watchdog resets the microcontroller. The watchdog timer can be configured for 10 different time settings. The various times are 16 milliseconds, 32 milliseconds, 64 milliseconds, 0.125 seconds, 0.25 seconds, 0.5 seconds, 1 second, 2 seconds, 4 seconds, and 8 seconds. Now, a word of caution: the watchdog timer is disabled at the start of the code. As you guys can see here, the watchdog timer is disabled at the start of the code. A delay of 3 seconds is used before enabling the watchdog. This delay is important in order to let the bootloader in Arduino to check if a new code is being uploaded and to give it time to burn the code into the flash. This is important as a precaution. A situation may occur wherein, due to faulty coding or improper considerations, the code written resets the microcontroller at very short durations infinitely. This will damage the Arduino board and lead to sketches not being uploaded to the board. Now, the WDT enabled WDTO underscore 2 seconds. This enables the watchdog timer with a timeout of 2 seconds. And the WDT reset resets the watchdog timer. So, what does this code do is that this code enables the watchdog timer to a timeout of 2 seconds. Then the void loop starts executing, and it blinks the LED for some time. And and the WDT reset keeps executing for each iteration. So therefore, the watchdog timer doesn't time out. But after 20 iterations, the while true loop is executed. As you guys know that this is an infinite loop. So since the watchdog timer is not being reset, the watchdog timer will time out to 2 seconds and it will initiate a system reset. As you guys can see here, the watchdog demo starting is being printed, which is actually at the beginning of the code. This is to ensure that whether the watchdog timer is being executed, watchdog timer code is being executed properly or no. So after this watchdog demo starting is being printed, then the LED will blink for some time, and then while loop will be called, and then the system will undergo a reset. Therefore, watchdog demo starting is being printed again. Now here are a few references for so that you can get a deeper understanding about the watchdog timers. My task at Fluxion was to develop a function which takes in the timeout window and it doesn't reset the Arduino code before the timeout window, and it resets the Arduino code after the timeout window. And you can also use the watchdog timer. You can also code the watchdog timer without using this WDT enabled WDTO underscore 2 seconds. Well, instead of calling this function, if you can hard code this function. The watchdog timers has a couple of registers. So if you hard code the registers, then instead of WDT enable WDTO underscore 2 seconds, you can use those registers to do the same function as functionality as this function in order to get a deeper understanding.
Thanks for watching. Subscribe and click on the bell button as to not miss out any content. Contact us here.